Alright everybody, welcome to another video. On this one, we're going to be talking about the beginnings of congruency in triangles and congruency between triangles, which is something new. So, what we're going to have is, by the end of the lesson, you should be able to identify corresponding parts, which you'll find out what that means, and determine if figures are congruent to each other, and then you will identify corresponding parts of congruent figures in order to write congruency statements for the figure. So, you're going to see what that all means coming up in the next few minutes. Here we go. So, congruent figures are two objects with the same side lengths and angle measures. So, one really easy way to make them, for me at least, is if I go up here to shapes, let's go back to this one, and let's say I make a triangle. There's one. And if let's go to the little one. If I select the triangle, and I hit copy, and then I hit paste, right over there we have an exact duplicate of it. Those are definitely congruent figures. So, that's a good thing. Now, one thing I want you to notice is that if I select the figure and I rotate it around, they're still congruent figures because they still have the same side lengths and angle measures. Orientation doesn't matter. All that matters is that the sides are the same and the angles are the same. Now, let's say that I label these parts of these triangles, and I call this A, B, C, and I call this one, I call this one D, E, F. Based on how the triangle originally was, D was in the same position as A, E was in the same position as B, and F was in the same position as C. And these are corresponding parts. Parts of two congruent figures that match up. Referring to above, some examples that we have are angle B corresponds to and means is congruent to angle E. We could say that side AB is congruent to side ED. There are many different little parts of these statements that we can make based on what is the same and what's different. And those aren't the only two that we could make, but those are two that are true. We can see that B and E are both right angles, and we can see that if we rotate the triangle around, ED matches up perfectly with AB. And we know they're the same size because I just copy and pasted the triangle. So, that is corresponding parts and congruent figures. Moving on, here's an example that uses this idea. We're told over here that DEFG is congruent to SPQR. Now what that means is it's actually giving us a lot of information because it tells us not only that the two shapes are congruent, but it tells us what is congruent in the two shapes. It's telling us here that D matches up with S. So if you were to look at the angle of S, that angle is going to be the same size as angle D. So since we know that angle D is 102 degrees, we know that angle S is 102 degrees because they're congruent. They're the same. And we can use this idea to help us find the value of X and find the value of Y. For instance, we can see over here that X is found in this. That was interesting. Hold on a sec. in this length over here, QR, we can see X is involved. And we can see from this that QR matches up with FG. So let's look at FG, and we can see that FG has a length of 12. That means that these two have to be the same. So that means that 2x minus 4 equals 12. So we add 4 to both sides, and we divide by 2 on both sides. And that gives us that x equals 8. Similarly for y, we can see that y is involved over here, along with x, in angle Q. And we can see that angle Q matches up with angle F. Angle F is 68 degrees. So that means that 68 equals 6y plus, and what we just discovered for x was that it was 8. So we replace the x with 8. And we subtract 8 from both sides. 60 equals 6y. Divide by 6, divide by 6. Y equals 10. And there we have x and y. And we use corresponding parts to find them. So that's good. Next up, we need to determine whether or not the two triangles are congruent. And at the moment, the only way we can do that is if we know that all the sides are the same length and that all the angles are the same size. So what we need to do is identify all of them. And we need to figure out, well, we need to figure out why they're congruent. The sides are going to be really easy for this one because they tell us everything we need to know. For example, they tell us that side triangle again. What is going on with that? All right, anyway, let's try this one instead. Side PS is congruent to, and we can tell because this has one line, and so does this. So PS is congruent to RQ. And likewise, we know that PT is congruent to RT, and we know that ST is congruent to QT. And the reason that we would say for all of these is just one word. What you would say as the reason for these, the why, is that this information was given to us. And if you ever write given, what that means is it was a piece of information that was given to you in the problem. You didn't have to figure anything out. It was written on the paper for you. The angles we're going to need to get from a combination of informations. One thing that we can see is that here, these two angles, this one and this one, are vertical angles. So we're able to say that angle PTS is congruent to angle RTQ, and the reason for that would be vertical angles. The other two are a little trickier, but if you look here, triangle again, let's try this marker. Those symbols, remember that that means that PS and QR are parallel lines. If we extend these lines a little bit, what you can see then is that PR is a transversal to those parallel lines, and SQ is a transversal to those parallel lines. And what that's doing then is that's creating some alternate interior angles. Along PR, we can say that this angle here is the same as this angle here. So we can say that angle P is congruent to angle Q, and likewise, we can see that this angle is an alternate interior angle to this one. So we can say that angle S is congruent this one is congruent to angle Q, And I messed up, everybody. You'll want to fix this. This one should actually be angle R. But once you see that, you can see that we have two pairs of alternate interior angles. This is going back to chapter 3 a little bit. So the reason for these ones is, triangle again, alternate interior angles. So you may want to have that green sheet available to you because that stuff is going to be coming back a little bit for this chapter. Now, to write a congruence statement for the triangle, what we're going to do is we're going to match up parts of the triangle that we know correspond to each other so that they're in the proper order. Let me clean up the picture a little bit for this part, just so we can see the basics again. Make it a little bit easier. So, one way you can see what's going on here is, if you look as we go along the triangle, let's start at point S on this one. If we go down the side that has 1 marking, and then down the side that has 2 markings, the order that we encounter the letters in is S, followed by P, followed by T. So we could say triangle SPT is congruent to, and then all we have to do is do the same path in this one. So what we'll want to do is go down a path that travels down the 1 prong 1 first, then go down the one with 2. So if we do that, or to do that, what we should do is start at Q, go down towards R, which takes us down the 1 prong path, and then go this way. So that means that we have QRT, triangle QRT. So that congruency statement will work because S matches up with Q, P matches up with R, and T matches up with itself in the construction of this triangle. Last idea in this one is that it's the third angles theorem. And basically what it says is, if 2 angles in 2 triangles are congruent, then the third angle is also congruent. And this is because if 2 of the angles in a triangle are congruent already, that means that the last angle has to complete 180 degrees in both triangles. So it's going to have to be the same size in both. Now in this particular problem that we have in front of us, we can use that because, well, first of all, given this symbol right here, we know that if this one over here is 68 degrees, then this one over here is also 68 degrees. Further, we can see here in the middle of the 2 triangles that we have a pair of vertical angles, which means that they have to be the same. Since angles D and S are congruent, and angle DNC and RNS are also congruent, what that means is that the third angle will also need to be congruent in the triangles. And we can see in this picture that we were given the third angle, right here, is 75 degrees. That means that this angle here, also 75 degrees. So, that is how that particular one works. And that really is the end of that information. So, hopefully that helped you out. See you next video.